Hello and welcome to 3-4. Today we're going to be talking about scientific notation. Now this is a very tricky topic, and so please make sure you're taking very good notes. I think that will really help you remember for tomorrow when we do our assignment. So let's get started. Alright, so I want you to write this down, please. It's step 1, step 2, step 3 on how to write a number in scientific notation. Okay, so step 1, we have to move the decimal, which in this one it doesn't look like there's a decimal, but there is a decimal right here. Okay, so if the decimal is right there, I need to move the decimal until it makes a number that is greater than or equal to 1 and less than 10. Okay, so I have to move it. Keep moving, I'm not too right here. So I'm going to move it until it's between the 5 and the 8, because that would make a number of 5 and 834 thousandths. Okay, so I would move the decimal till it makes a number that is greater than or equal to 1, less than 10. That's the important key part there, you guys. We need to make sure we write all these steps down, but that's the big thing you need to remember. Greater than 1, less than 10. Now, how many times did you move the decimal? Well, let's count. We moved it 1, 2, 3, 4, 5, 6, 7 times. Okay, so write the number in this format. Your number between 1 and 10, so that would be 5 and 834. I don't need to get all those zeros in there. That's just unnecessary to write them in because it doesn't change your number. Okay, and then you're going to write multiply by 10 times the number, and then it's going to be like written in exponential form. So in your exponents will be the number of times you move the decimal, which in this case was 7. 10 to the 7th power. So this right here, you guys, is written in scientific notation. Okay, so if they're asking you to write something in scientific notation, they're looking for this format. A number between 1 and 10 times 10 to the number of times you move the decimal point. Now, I guess I should discuss here, what is scientific notation? Why do we use it? And here's the deal, why it's scientific notation. Because when we're looking at science, we're looking at like planets that are millions, billions, trillions miles away. Okay, and so if we're going to talk about really big numbers, and then also in science we look at minuscule little things, and we have to have a way to measure them. So we're using really tiny microscopic numbers. So scientific notation is a way for us to write those numbers without having to waste all of our time writing 0, 0, 0, 0, 0, 0, 0, 0, 0, like 100 zeros, right? So scientific notation saves us time and makes a lot of sense. Because we're working with really huge and really small numbers, and if you're trying to look at a number that has so many zeros, you're going to get stuck on what is that number. Okay, so that is what scientific notation is. So let's do some more problems here. Find each product. So if I'm going to multiply a number by 1,000, I'm going to take my number 4325. I'm going to count how many zeros am I multiplying it by. 1, 2, 3. So that's how many zeros I need to add. 1, 2, 3. Then I'm going to go back in with my commas. Okay, I have to have a comma in every third number, every third digit. So I'm going to count 1, 2, 3, put in my comma. And then I'm going to count 1, 2, 3, put in my comma. Okay, so that's my number there. Okay, do I need you to show me you can multiply it out? No, because this is how you're going to do it. It's much easier. Okay, now things do get a little bit trickier though. We just need to count how many zeros we have again. 1, 2, 3, 4 zeros. Okay, now here's the deal. A lot of you might say, okay, so 2 and 54 and put 4 zeros. Now that doesn't change the number at all. Right? That's still writing the same number. I'm just putting a bunch of meaningless zeros after the decimal point. So really what this is doing is this is telling you how many spots to move your decimal point. And if you think about it, that's all we did here. We had the number 4,325. My decimal point was here, and I moved it 4 spots. But the decimal point was at the end. So when the decimal point isn't at the end, we just have to move it this was 3 times, not 4 times. We moved it 3 times. We just have to move it 4 times. 1, 2, 3, 4. So now my number is 25400. Put in my commas, 25,400. Okay, I just move my decimal however many zeros there are. So this works for 100, 10, 100,000, 10,000, 100,000, million. It has to be, one of our place values. And that's why it works, because we're just moving our place value, our decimal around. Okay, let's go to another one. So now we're going to write this number 8,296,000 in scientific notation. So remember back to our steps. Our first step is to move the decimal point until it makes a number greater than or equal to 1 and less than 10. So my decimal point's going to go here between the 8 and the 2. So I'm going to write that down. 3 zeros. Okay, how many times did I move the decimal point? 1, 2, 3, 4, 5, 6 times. I can count my jumps. 1, 2, 3, 4, 5, 6. Okay, so then my third step is to write it in this format. 8 and 296 thousandths times 10 to the 6th power. Okay, I have step 1, step 2, step 3. I followed them all. I can check my work by doing 8 and 296. And then I just have to move my decimal 6 places, and I should get the same number as what I started with. 1, 2, 3, 4, 5, 6. And then I'll put in my zeros on these blank spots here. So I'd get the number 8,296,000. Put in my commas. 8,296,000, just like what I started with. Okay, that's kind of how you check your work to make sure you wrote the right number for your exponent. Okay, let's look at the next one. So now we have to know, what is standard form? Now standard form is just what we said, 8,296,000. That's standard form. Okay. So let's look at how we would do this. So first, step 1, we just write down the decimal, 3 and 2/10. Now remember, the 7 tells you how many times to move that decimal point. Okay, so let's go. 1, 2, 3, 4, 5, 6, 7. I have a lot of zeros to fill in here, you guys. 1, 2, 3, 4, 5, 6 zeros to be exact. Okay, so now I'm going to write down my number. 3, 2, and I need 1, 2, 3, 4, 5, 6 zeros. Now I'm going to go back every third digit, put a comma in, 32 million is what number that is. Okay, so again, I just write down my decimal. Our exponent tells us how many times I need to move the decimal point, and then I write my answer down. Let's look at one more problem here. Write the number of dots in Seurat's painting A Sunday on La Grande Jatte, I don't know how to pronounce that. 3,456,000 in scientific notation. Okay, so first step, move the numbers, move the decimal point so it is making a number that is greater than or equal to 1, less than 10. Which would be right here. 3. 3 is greater than 1, less than 10. Okay, then ask yourself, how many times did you move the decimal point? Let's see. I'll use a different color here. 1, 2, 3, 4, 5, 6 times. Okay, I'll write that over here. 6 times we move the decimal point. So now I'm going to write my answer in scientific notation, which first I write my number that's greater than or equal to 1, less than 10. 3 and 456 thousandths times 10 to the 6th power. Okay. Now I hope you took really good notes for this because it's really going to benefit you tomorrow and for the test to be able to know what each step along the way is. So if you have any questions, please write them down, so make sure to ask me. Other than that, I will see you tomorrow. Have a great night.